are tackling the first of 5 rules for how to simplify an exponent expression. We focus PO9 on what an exponent expression is, what it means, what a coefficient is, a base, a power, all that sort of stuff. Now we're going to be working on actually doing operations with them. Okay? And our goal, you'll see there are no equal signs anywhere. Okay, we're not looking to solve for anything, not solve for the variable. We want to simplify these expressions. Then we're going to start by going back to expanded form, just to help us. And then eventually we're going to be able to use a rule, okay, that will make things much more efficient. I am using a new smartboard today, so anything that goes wrong, we're blaming it on technology and not on me, and certainly not on you.
Okay.
All right. So to simplify an exponent expression is to write an exponent, I really got to work my penmanship here. Exponent expression, I got to write nice and slow. Exponent expression by combining all like bases. Okay. Well, it is kind of like terms. That's essentially what we're doing here, but our like terms in this case are the like bases. So that's what we're going to be looking for. Okay? To write an exponent expression by combining all like bases. From your end of things, is it easier, harder, or the same to see this screen from where you are compared to the other one?
This one's bigger.
Darker, so harder. Harder to see?
I like
Okay.
the other one better.
You like the other one better? Okay, all right.
It feels smaller and like
Now, what I don't know is if we go with this model, if this would be mounted, so it's not on carts like it is currently. This is just we can wheel around from teacher to teacher. So I don't know if it would ultimately end up getting mounted or not, but we shall see. Okay. Yes, Claire.
I'm pretty sure they said it would be on carts, so then like the teachers can separate into groups, like move it around. And I think it's better for like the younger kids, like these kind of smartboards, but for the older kids, I think the other one's works.
Sure, that's good feedback. Very, very good. Yeah, Asher.
Why do we need new ones? The old ones work fine.
Not all of them do. Some of them are in pretty rough shape. Mine works very, very well, but others don't. Plus, I got that Sharpie on my board, which they got to replace the entire thing. So, yeah. I could stand right by you and teach. Yeah. I do need to be. I'd have to unplug it and plug it back in. I don't know if that would affect things. So. Anyway, I stand by you and teach anyway. Consider the examples below. It says first write each expression in expanded form, and then look at what can be combined so that the expanded form version is just one term. So take a look at the first one here. Okay, 3 to the 4th times 3. If we write this 3 to the 4th in expanded form, it's 3 times 3 times 3 times 3, right? Okay? And then, if we multiply that by the 3 that we have here, how can we rewrite that as one expression with one base and one power? Madden. 3 to the 5th power. Okay? So 3 to the 4th times 3 becomes 3 to the 5th. We'll come back to that in a little bit. The next one. 7y, I also know how to change color of pen. That I'm still working on that one too. 7y cubed times y to the 4th. If we rewrite this in expanded form, there's 1 7, and then times y, times y, times y. Right? 7y cubed. And if we multiply that by y to the 4th is y times y times y times y. How can we rewrite that as one term with one base and one power? Essentially, how many y's do we have in all there? Grace. Sorry? Not 7 to the 7th. You're missing one little piece there. 7y to the 7th power. There's still only 1 7, right? Our base being y, there are now 7 of them. If we start with 3 and then multiply 4 more, because of what an exponent means, it's repeated multiplication. we start by multiplying 3 of them, right? Then get 4 more of them, total, that is 7 y's all being multiplied together. Okay? The last one, 8xy squared. What's that in expanded form? 8xy squared. Yeah, Lucas.
8 times x times y times y.
Good. 8 times x times y times y. There's one 8, there's one x, and then y squared means there are 2 y's. How about 5x squared y cubed? We're multiplying that on. Grayson.
5 times x times y times y.
Yeah, 1 5, 2 x's, and 3 y's. Okay? Have I lost anybody yet? Writing in expanded form?
You kind of lost me.
How?
So we're starting by writing these in expanded form. This was PO9 here, right? The reason why we can write this as 5 times x times x times y times y times y
I like all
is because 5 is a coefficient. James, well, don't stand up right now. If you need more explanation, then don't walk away. 5 is a coefficient. How many are there? 1. 1, 5 there. X squared means x times x, and y cubed means y times y times y. So those that said that you were lost, what questions do you have? Because if you don't get this, then I don't want to move on to the next time.
I got it.
You good? Okay? Yeah?
I'll just have the answer.
Okay? Now, because of the commutative property that says we can multiply things in any order, I can rearrange these because the only operation here is multiplication, right? Nothing else. So I can rearrange these so my numbers are together out in front. My x's, I've got 3 of them total. I can make it so I'm multiplying all of them right next to each other. And my y's, I've got 5 total. I can make it so I'm multiplying them right next to each other. Right? It would be just like if I had something like 2 times 3 times 4. If I rearrange that to be 4 times 2 times 3, it's the same answer. The commutative property says when you're multiplying things, you can put them in any order. Right? So I just regrouped these so numbers are together. X's, 3 total, are all together. And Y's, 5 total, are all together. How do I write this as one term? Go ahead, Lately.
8 times 5 times x to the power of 3 times y to the power of 5.
Yeah, and can I take 8 times 5? What is it?
40.
40. So ultimately, I can rewrite this to be 40 x cubed y to the 5th. Because my coefficients, 8 and 5, can multiply together to make 40. I've got 3 total x's all being multiplied together, which is x cubed, and 5 total y's all being multiplied together, which is y to the 5th. So, what patterns are you noticing here? So that if we were to write a rule for what happens when this is called multiplying by the same base. What happens to our coefficients when we multiply by the same base? What did we do with them in that third example there? Good morning.
Good morning. Sorry for the interruption.
Oh, yeah. Perfect. Thank you.
What's that?
Lucas, what do we do?
You just, you don't multiply, like you put them out. You don't put them in 8 times 8 times 8, just leave them there.
Right, and what did we do with the 8 and the 5?
We put them next to each other.
And then did what?
You multiply.
We multiplied them, okay? So when you multiply by the same base, the rule is the coefficients get multiplied, like we did with that 8 times 5 there. How about the exponents? What did we do with the exponents? I'm going to see if I can change color. Hold on, I'm going to press this, go to this, I think the pen.
Oh my goodness.
Red.
Rainbow. Do pink.
Pink,
Rainbow.
pink.
I want red.
Rainbow.
Spirit of Christmas, I want red. Okay, what did we do with the exponents?
We added them.
We added them, right? Going all the way back to the first one here. This really, oh, that didn't work. This really has a 1 on it, even though it's not written. A 3 by itself is like 3 to the first power. 4 plus 1 gave us 5. Over here, we had 3y's times another 4. Total, as we can see in expanded form, that is 7. 3 plus 4 gave us 7. Over here, we had 1x, right? This is like x to the first. Okay? X to the first and x squared. We can see we've got 3 of them total. That's how we got the x cubed in our final simplified expression. We had 2y's and 3y's. That's a total of 5. And we can see the power of 5 in our final expression. Kyle.
To keep the color, you have to keep like that menu that has like the pen stuff
Oh,
up.
don't love that at
Well,
all.
try it.
Don't
It
love
works
that.
instead. No.
Exponents are added. Okay? And how about the base? What happened to the base? We started with a base of 3. We ended with a base of 3. Started with a base of y, ended with a base of y. Started with bases of x and y, ended with bases of x and y. Fiona? Stays the same. The base does not change. The base stays the same. Okay? When you recognize that you are multiplying by the same base, this is a rule that you can use that eliminates the need for expanded form. Expanded form will always work, but if you look at kind of what's coming up homework-wise, on the second page, I don't think you want to be writing expressions like this in expanded form, or x to the 10th, y to the 13th. That's not very, very fun there. 10 to 2, right? So we look at this rule, okay, and this can help us for when we get down to multiplying by the same base. The first 8, we do need to write in expanded form, because again, it's that practice, it's that reiteration. But then the second page, you can use the rule on it. So 6 squared times 6 cubed. 6 squared is 6 times 6. 6 cubed would be another 3 6's. And notice we have 5 6's in all. What's our answer? Not what is 6 to the 5th, but writing it as one term. Like, I don't want the final answer, don't evaluate it, but what would this be written as one term? Yeah.
6 to the power of 5.
6 to the power of 5. Guess what the most common mistake that folks make with this is?
What?
Do they multiply with both of the sixes?
Yeah, they put 36 to the 5th, right? Because in this rule, the numbers, the coefficients, do get multiplied. But is 6 a coefficient here?
No.
No, it's a base. It's what the power is attached to. And the base stays the same. Okay? So pay very close attention to when a number is a coefficient and when a number is a base. If it's a base, it doesn't change. Because if you did write 36 to the 5th power, there are no 36's here. We have 5 6's, not 5 36's. Okay? So this is where expanded form can be helpful. The next one, 10 cubed, 10 times 10 times 10 times another, 10 squared, which is 10 times 10. What is that in one term? Madden? 10 to the 5th. Not 100 to the 5th, 10 to the 5th. That base stays the same. The next one, 14x in expanded form is just 14 times x. And we're multiplying that by 10, x to the 5th. Okay? How would you write that as one term? Lauren? Sorry?
24 to the 6th power.
Not 24 to the 6th power. I see where you got the 24, 14 and 10 there, but remember, the coefficients get multiplied. It's the exponents that get added. So 14 and 10 being coefficients, they get multiplied. Kyle?
140x to the 5th power.
140, not x to the 5th. How many x's do you see there? 6. It's easy to think 5 because it's like, oh, that's like nothing. That's like a 0. 0 plus 5 is 5, but it does have a 1. It's not written, but it is x to the 1st. Expanded form, we can see very clearly we have 6 x's here. Okay? But if you're not using expanded form, you got to remember it is x to the 1st. Right? And the reason why 14 and 10 are multiplied is their coefficients. 7ny squared times 2n squared, so we have 7 times n times y times 2 times n times n. Combine what you can. What do you get? One term. Jude?
14n cubed and y squared.
Good. 14n cubed y squared. Where did the 14 come from? Our coefficients, 7 and 2. 7 times 2 is 14. Okay, yn cubed, because we have 3 of them. N times n times n. Exponents get added for the shortcut. N to the first plus 2 is n to the third. Y squared, only 2 y's we have, so it remains y squared. But you see why PO9 is a PO, right?
Yeah.
Without understanding what a coefficient is versus what a base is, this rule might not make a lot of sense anyway. Right? Without looking at it in expanded form, it's difficult to make that mathematical connection. So that's why 9 is a PO. Question on those first 4 there? Okay. Scroll.
Remember to erase everything.
What's that?
Remember to erase everything.
Thank you. I also can't, I don't know how to capture this. So if I need to print it for a student and print notes, I'm not sure how to do that.
Just take a picture on your phone.
Right, yes, brilliant. Right on that, yeah. Yeah, and then print to the printer with
You
my,
could use snipping
yeah.
tool. I don't think you can take a picture on a
Could
phone.
use a snipping tool, that would be
Just get a phone
an
from the
option.
drawer.
Okay, next one, 2 cubed times 2 cubed times 2 squared. Predict what it's gonna be as one term first, then we'll use expanded form and prove it. So by using the rule, predict what this is gonna be as one term. Practice that now, using the rule. Who's got a prediction for us what this is gonna be in the very end? Olivia.
2a.
2 to the 8th power is the, whoops, is the prediction, okay?
Yeah, there's gonna be.
Let's see, 2 times 2 times 2, there's our first 2 cubed, times another 2 cubed, so another 2 times 2 times 2, times a 2 squared, so another 2 times 2, right? 2 cubed, 2 cubed, 2 squared, how many 2's do we have in all? 8 of them. So 2 to the 8th is the correct answer. Not 4 to the 8th, right? Don't multiply the 2's, they're bases, not coefficients. 2 to the 8th. Predict what the next one is going to be. Write it on the bottom. We'll prove it or disprove it with expanded form, but predict what that one's going to be.
-27.
Didn't ask you to say it yet. Just write it down.
The answer.
Great. Write it down. Great. Okay, who's got a prediction for us? Will.
-27x to the 7th.
Negative 27x to the 7th. So in expanded form, we have a -3 times an x times another x, can't forget that. And then times 9x to the 4th, so times 9, only one of them. And then x times x times x times x. Where does the -27 come from? -3 times +9 is -27. Those coefficients get multiplied. Then we have x cubed, x to the 4th. The powers get added. 3 plus 4 gives us x to the 7th. Okay? The rule works, so is expanded form, but the rule is much more efficient. Lucas, we are nearly out of the time, so I'm gonna skip the last two and assign homework that is due tomorrow. Your homework for tomorrow is simplify each expression. The goal here is to not have to write the expression in expanded form.
Let's go.
If you need to, it's available, but the goal here is to use the rule instead. Okay? So this page, just this one page, due tomorrow. Questions, comments, concerns, complaints, compliments, congratulations, criticisms. Pay attention to what's a coefficient versus a base versus a power. Follow the rule. Okay? That is how you math.